Well, you've heard the phrase OpenMP, but now let's find out what that actually means. So here is OpenMP. We're just going to look at it simplified. Why? Because you've got Project Zero. And Project Zero is meant to be about the most cut down way of using OpenMP that you can possibly have. So let's not start with the big OpenMP nodes. Let's just start with the little OpenMP nodes, and that'll make it so you can do Project Zero pretty effectively. All right, first of all, OpenMP. The MP stands for multiprocessing. It really is there for multi-core machines, although you don't really need multi-cores. You can just do multi-threads. And when we talk about big OpenMP, we'll get into more to what threads really are. These are the consortium, the members of the consortium that runs OpenMP. If you've been with me in graphics classes, you know about the Kronos group. This is not under the Kronos group. This is a different consortium. But you can see that it's companies and it's even universities and it's government labs. So it's a pretty good group of organizations. All right, OpenMP, amazingly enough, is built into the compilers. Okay, when you get the G++ compiler, OpenMP is built into there. You just have to turn it on. You have to know how to turn it on. You have to know when to turn it on. You have to know what parameters to give it so that it does its job well. And so this phrase right here, I'm going to use that phrase all quarter long, and you're going to be sick of it. But doing parallel programming at all is not difficult. The trick is doing it well. Okay, so in this note set, we're going to see how to do it, how to turn it on. Then we're going to spend the rest of our OpenMP time talking about how to do it well, which is going to be another 3 weeks. Okay, so here's what you do is in your C program, you have lines that begin with a pound sign, pound pragma. Pragma is a word that means hint. So giving a hint to the compiler. OMP, that means it's an OpenMP hint. And then there's some stuff out here. And there's a bunch of different stuff that can go out there. Okay, now, if you want to use OpenMP on Linux, no problem. G++ has OpenMP built into it. Just use G++. Just compile like this. If you want to use Visual Studio has OpenMP built into it, but it's not turned on by default. But here's how you do it. You go to the project menu, project properties, you do this and this and this and this, and you finally come to OpenMP, and you change that setting to yes. Now, if you're using Visual Studio, every so often you will get this weird message that has absolutely no meaning in any language known to humans. Somebody figured out that this is how you fix it. What the fix means, I don't know. How anybody figured this out, I don't know. But if you get this message, here's how to make it go away. And this is only in Visual Studio. Okay, so, Linux and Visual Studio. And I believe on Macs this will work too, because I think G++ on Macs has OpenMP built into it as well. Okay, here's how to find out. Put in at the top of your program, and you'll see this in our sample code, if def underbar OpenMP. And so if that is really defined on the system you're on, it will execute this. And it turns out underbar OpenMP is a version number. Well, not exactly. It actually gives you a year and a month, and then you have to turn that into the version number yourself. But it tells you something about the OpenMP that you're using. Okay, so if that is defined internally, you print this out, and that tells you, yeah, I've got OpenMP here. Pound else, if that's not defined, then OpenMP is not supported on the system you're on. Now, if you're on Visual Studio, what that might mean is you simply haven't turned it on. That is, if you don't turn it on, you will get that not supported message, even though it is supported You just have to turn it on. And then you might as well exit because you're not going to do anything useful here anyway. If you find out that version number is November 2018, you're on an OpenMP 5. November 2015, you're on 4.5, and so on. So this number will tell you a little bit about where you are. All right, we will get into threads, not quite now, but coming. But know for now that a thread is just an independent execution path through your program. Okay, and threads are at their very best when each one can run on a separate hardware core. Again, we'll get to that. To find out how many cores are on your system, there's a built-in function, OpenMP get number of processors. You can just print that out and say, yeah, hey, here's how many processors I have on my system. How many OpenMP threads you want to start using. And we'll use this function call a lot. Or how to use one per core. Well, you can find out the number of cores with this function call and pass it right into that function call. So again, OpenMP consists of these pragmas, these hints to the compiler, and certain function calls. And you don't have to link up the library. It's just automatically there. All right, here's what you need to know for Project Zero. And this is actually the coolest use for OpenMP. So you've got a for loop. The for loop is doing something. Yes, your Project Zero for loop is doing something. And right in front of the for loop, you say pound pragma, a hint, OpenMP, here's what the hint's all about. Parallel, we want to parallelize this. We want to parallelize a for loop. And forget about the default none. We'll come back to that. And then you put in your for loop. Well, what this hint causes to happen, oh, and up here you've set the number of threads you want to use. So let's say this is 4. Numt is 4. Well, what we've done is we have set this up so that it will break your for loop up into 4 pieces. And it'll give 1/4 of the for loop passes to the first thread, and 1/4 of the for loop passes to the second thread, and so on. And so that means that 4 groups of for loop passes are all running simultaneously, which means in theory they should run 4 times as fast because each pass has 4 or 1/4 as much work to do. Okay, and that is Project Zero. You're going to run this twice, once with numt set to 1 and once with numt set to 4. And then you're going to observe what the difference in performance is, and you're going to create a number called a speed up, the fast version divided by the slow version. In theory, you should get 4. You probably won't. There's always some friction in there somewhere, but you should get close to 4. 1 thread to 4 threads. Yes, you should get close to 4. And then from that, you'll compute something called a parallel fraction, which I'm not going to tell you about yet, but we will get to that soon. And when we do, the number you got for the parallel fraction in Project Zero will have meaning. Will have meaning to you because it was your test.